Hello. So um, we are continuing our lessons from the last time. We look at the exponents law. Then we started with only one. Today we'll look at the rest of them and then see if we can work some few examples on them. So exponent law. What we looked at the other time was the product of powers. Product of powers that says that a exponent m times a exponent n is equal to a m plus n. So that was the first one that we look at. That is the product of power. Product of power. So today we look at the other ones. This product of power. So this one is product of powers. Now we're looking at quotient of powers. That is division. So that says that a exponent m divided by a exponent n is equal to a m minus n. So just the inverse or reverse of the product of power. So this one is quotient of powers. That is division. Quotient of powers. That is division. So just like the product, you maintain one of the base and then you add the exponent. The quotient, to instead of adding, you subtract. So it's just the inverse, the reverse of it, the opposite of it. So instead of adding the powers, you subtract if they are divided. We'll look at examples later on, so I'm just putting in this thing. And then the other one, power of powers. So if I have a exponent m, power exponent n, this one should give me a m times n. This one is power of a power. So if I have a base and exponent all multiplied by another exponent, I just multiply the exponent. Just multiply the exponent. We look at an example of it. And then power of a product. Power of a product. Power of a product. That's, let's say if I have AB exponent m, this one should give me a exponent m times b exponent m. A exponent m times b exponent m. This is power of a product. Power of a product. So power of a quotient would just be the inverse of it. So if I have a out of b all exponent m, it should give me a exponent m over b exponent m over b exponent m. B exponent m. Our b should not be equal to 0. Our b should not be equal to 0. And then this one is power of a quotient. Power of a quotient. So these are the few exponent laws, and then like this will be the basics. You can apply them in any exponent work that you are given. Can apply them in any exponent work that way. So you're just going to do examples of it, and then see the application of all of these laws. All of this law. If you remember from our previous lesson, we talked of any number exponent 0 is 1. That is the 0 exponent. And then any number exponent 1 is the same number. The number exponent 1 is the same number. Then we talk of negative exponent, that it is 1 over the positive exponent. So those are all things that you need to apply. So now let's look at the application of it. Do this here. Okay. So the first one that we're looking at is we're going to do a, let's see, 5 exponents 8 times 5 exponent negative 3. So looking at this question, you could see that they have the same base. So this one, we can apply product of a power. Product of a power. So the solution for this one, we're going to have 5 exponent 8 plus negative 3. And this one's going to give us 5 exponent 5. 5 exponent 5, which is 5 times 5 times 5. So this one is, we could use the product of powers. Okay, let's look at another one. Okay, or another way you can do this one too. Let's see another way that you can do this one too. This one too can, because 5 exponent 8. So another way you can do this is 5 exponent 8 times 5 exponent negative 3, because we talk of negative exponent, so this one could give us 5 exponent 8 times 1 over the positive exponent 5 negative 3. So this one is going to give us 5 exponent 8 divided by 5 exponent 3. And then if we used the quotient of powers, they have the same, so we're going to subtract. So 5 8 minus 3, which will give us 5 exponent 5. So you can use any way and then you still get it. So far as you are doing it right, you shouldn't have any problem. Anyhow you do it, you should get it if you are only following the rules, if you are following the procedure. Let's look at another example. Okay, so another example I want us to look at is 0.8 exponent negative 2 times 0.8 exponent negative 4. So the same, just as we did 8, you can use both method and then you should get the same thing. So if I'm doing 0.8, one of the base, and then I add the exponent, so negative 2 plus negative 4, negative 2, and this one is going to give me 0.8 exponent negative 6. 0.8 exponent negative 6. Or I can change it to positive exponent, and then I will still work it out. I'm going to get the same thing. Let's look at more examples. So if I have 2x exponent 3 over 2x exponent negative 2, 2x exponent 3 over 2x exponent negative 2. So the bases are the same. So what I can do with this is going to have 2x. Since they are dividing, I only need to subtract. So 3 minus negative 2. And then 3 minus negative 2 give me positive 5. So 2x exponent 5. And then that would be for my answer. Put it in parentheses. If I don't put it in parentheses, it will mean a different thing. So all should be in parentheses. So I get 2x exponent negative 5. Or if I want to change it to positive exponent before solving it, I can still do that, changing it to positive exponent before solving it. 2x exponent 3. You don't have to do the 2. You can still do 1, and you should get the same as exponent 2. And then now they become positive, and because there is a negative, and then it's going to be, if you reverse it, it's going to be a positive. So the negative exponent becomes a positive exponent now. So now this becomes 2x 3 plus 2, and then you get your 2x exponent 5 in your parentheses. You put them in parentheses. If you did not bring the parentheses, then it should be 2 exponent 5 x exponent 5. If you don't bring the parentheses, that is what it should be. Don't get confused with this because it's something you're going to apply it. So just understand the concept, understand the basic rules, and then you'll be good to go. Be good to go. So let me give you some examples to do. Okay, let's work some examples before I give you final examples to do. So let's work more examples. What about, let's see this one. 4 exponent 3 in parentheses negative 2. Yeah, so if this happens, then you multiply the exponent. So you're going to get 4 exponent 3 times negative 2, which will give you 4 exponent negative 6. 4 exponent negative 6. And then 4 exponent negative 6 could be written as 1 over 4 exponent 6. 4 exponent 6. So if you put your 4 exponent 6 in the calculator, you're going to get 1 over 4096. 496. So that is what this answer is going to be. That's what this answer is going to be. Let's look at another one. I'm just applying. So this one was the power rule, power of powers. So let's look at another one. If you have 2 exponent 4 over 2 exponent 6, all exponents negative 3. So anyhow you want to work it, you should still be able to get the same answer. If you want to use the power rule first, or you want to use the quotient rule first, any of them should work. But here, let's first of all do the quotient first. So this one is going to give me, like, just working out what is in the parentheses. So I'll put a bracket here, and then I'm going to do 2 exponent 4 minus 6, and then I will close my bracket, this one here, and then this negative 3 comes here. So I just did 2 exponent 4 and then 2 exponent 6. So that gives me 2 exponent 4 minus 6. So this is going to give me 2 exponent negative 2, negative 3, negative 3. And then when power of power, so you multiply. So 2 exponent negative 2 times negative 3, and that should give you 2 exponent 6. That should give you 2 exponent 6. 2 exponent 6, and 2 exponent 6 is 64. 2 exponent 6 is 54. So just raise your, yeah, just work it, and let's see, let me try to use the other method too here. So if I want to do the powers first, so I could do is 2 exponent 4 over 2 exponent 6 all in negative 3. So I'll just multiply everything. So this one is going to give me 2 exponent 4 times negative 3 over 2 exponent 6 times negative 3. 6 times negative 3. So here I'm going to get 2 exponent 12, negative 12. 4 times negative 3 give me negative 12 over 2 exponent negative 18. Over 2 exponent negative 18. So now they have the same base and they are dividing. So if I use the power of quotient, I'm going to get 2 negative 12 minus negative 18. And negative 12 minus negative 18 is going to give me 6. So 2 exponent 6, which is 64. So you see, anyhow you use it, any method that you use, you should get the same answer. Any method that you use, you should get the same result. So all that you need to do is remember the method and then just apply them as it is. Just apply them as it is. So I'm just going to give you few examples, and then you try your hands on them. To give you some few examples that I want you to try your hands on. So those are going to be like all of them. So the first one, write each expression as a positive exponent. Okay, well, let me just give you some examples here. Okay, so simplify this one, just do this one. 1, 2 exponent 2 exponent negative 3, parenthesis close, another parenthesis open, 2 exponent 5, 2 3y exponent 2 over 3y exponent negative 6. And then let me put 3 here. X exponent 6 over x exponent 4, or in parentheses exponent -2, then 4 in the parentheses y exponent 2 exponent 0 over y exponent 3 exponent -3. So y exponent 2 exponent 0 over y exponent 3 exponent -3. Okay, let me see if I could get another one to add to get 5 questions for you. Okay, so number 5. Number 5 is going to be 3 exponent -4. So just write it as a positive exponent. Just write this as a positive exponent. So these are the 5 questions that you could do. Let's go over it quickly. We did a product rule, so these are all that. This is just examples, but this oh, yeah. So these are the rules that you're supposed to remember. The product, when the base are the same, you add the exponent and they are multiplying, add the exponent. When the base are the same and they are dividing, you subtract the exponent. When you have an exponent being multiplied by another, you just multiply the exponent like this, m times n. And this one, the power of a product, the exponent applies to everything in the parentheses. So a exponent m, b exponent m. And the same thing to power of a quotient. So we solve examples of it, and then you have this 5 examples to look at and then solve them. So I think with this you should be able to do it. If you have any question, you let me know about it, and then I will still guide you with it. Yeah, so this is just a brief overview of what you're supposed to do. Thank you.